So in our last video, we sort of defined a screw and sort of explained how it works and how it operates. Well, this video is going to be more about how to actually calculate mechanical advantage. And hopefully the actual mechanical advantage, we don't really need to discuss how to figure out. It's just Fe and Fr again. It shouldn't be too hard to figure out which one is the effort and which one is the resistance applying or fighting back. But the IMA can get kind of tricky. So I wanted to take the time in this video to sort of explain how the IMA works for a screw. Because it might get a little confusing. It might be which one is the DE and which one is the DR. How far is the screw traveling? How far is the effort traveling? And so on and so forth. It does get a little dicey, so I wanted to make a video just sort of explaining that. So, well, we know IMA is still DE over DR. It hasn't changed. It hasn't stopped being this formula, DE over DR. But the question is, what is DE and what is DR in a screw? Or in this type of a simple machine? Well, to figure this out, we just literally have to define how far is the effort traveling and how far is the resistance traveling. So if you look as this screw spins around, you kind of think of the effort as where my hands go, where am I applying my effort? And it would be on the outside of this screw spinning. And you might say, what's the resistance? Well, it's the traveling of the screw linearly, or just the traveling of how far the screw goes in a straight line downward in this case. And I want you to pay very close attention here. As this sort of wheel, or in this case a screwdriver, as it spins around once, I want you to look what happens to the screw. As it makes one full rotation, the screw travels one thread downward. And we can use this concept to figure out what DE and DR are. So let's go ahead and make that note for ourselves to help us figure or define DE and DR of a screw. So twisting a wheel around once moves the screw down one thread. Let's go ahead and write that out real quick. Let's make a little text box for ourselves. Let's move this out a little bit further so we have plenty of room to write. Let's say it. Let's put a little dash for ourselves as well. Twisting the wheel, and I'm going to put wheel in quotations because it's not really a wheel, but it kind of is, depending on how you think about it. But it's the screwdriver, or in some cases a wrench, or whatever. Sometimes it's just your fingers around the screw, but the wheel, what we will call the wheel, twisting that around once, moves the screw down, basically just one thread downwards. So with this, we can go ahead and define what DE is, what our distance effort is. So we write it out, DE. Well, DE would be the twisting of the wheel. It'd be the spinning of the wheel. That's where I apply my effort. I spin it around in a full circle. So if I go ahead and get my text box out, I can just write that out, equals one rotation of the effort arm. Or another way to put it is it equals the circumference. Let's try writing that out better. Circumference of the effort force rotation. Effort force rotation. And with that, I want you to go ahead and underline the word circumference. Because that's the key word here. It's the spinning, it's the full rotation, or the circumference. That is what DE is. The circumference of my effort. Circumference. There we go. Make sure we spell it somewhat correctly. And so that's the number that goes on top. And of course, circumference, the formula for circumference, is just 2 pi r. Or another way to write it is pi times diameter, because 2 times r is just the diameter. And so that makes sense, though. That's the circumference is the spinning of that wheel. That's my effort distance. And then my distance resistance would be how far the screw is actually traveling every one rotation. Let's go ahead and write that out. So we write out dr and we set this equal to, let me go ahead and make this a little bit wider. We set it equal to the linear distance traveled by the screw during one rotation of the wheel. Or if we look at our video again, what is the linear distance traveled? Well, it's traveling one thread every rotation. So it's traveling down one thread every rotation. We can write that out as well. Or we can, instead of just writing it as well, what I could say is we could redefine it by saying it equals the distance traveled between the threads, the distance between the threads. And we can look what that is. If you look at the distance between the threads, what that's defined as is what we call the pitch. So dr is also equal to the number known as the pitch. And that's the key word that goes on bottom. So we underline that and we write it out. We write out pitch on bottom. That is the dr, the distance between the threads, how far it travels every rotation. And you might say, well, Mr. Anderson, the circumference was really easy to calculate. I already knew that term. I already knew how to define it. How do we define pitch? Well, it is right here. The threads per inch tells you the pitch. And you kind of have to think about it. If it's 13 threads per inch, that means if I were to draw a line right here, in between each thread, and I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That would mean that from this thread to this thread is 1 inch. Well, if we look, the pitch, that means there's 13 pitches here. So we use the second number. You can go ahead and pretty much, as far as calculating mechanical advantage of a screw goes, this first number is really not helpful. You can even go ahead and cross that out. I know it says diameter, but it's telling you the diameter of the threads, and that doesn't really matter. The only number you really need to concern yourself with as far as calculating mechanical advantage of a screw is the second number. So basically, to find pitch, we're going to use the number of threads per inch to find it. The number of threads per inch to find. There we go. And so again, if we look, if this is 1 inch long and there's 13 of them, that means there's, or 1/13 of an inch is the pitch. Because then 2/13 would be 2 pitches and 3/13 would be 3 pitches. If we do 13, take the pitch 13 times, we'd get a total of 1 inch. So the pitch would be 1/13 of that. In other words, pitch is very simply 1 divided by the number of threads per inch. So if you take the second number of your thread note and put it on bottom, and you put 1 on top, you will get the pitch. And then you will take this entire number here, and you'll put it right here. And that'll give you the IMA of your screw. Now, to be clear, just finding the pitch would not give you the IMA. That will not be the total IMA. That'll just be the number on bottom. You'd put it underneath your circumference that you already found. Now, hopefully this made perfect sense. This was too easy, too obvious. But if it's not, fear not. The next video will have a math example applying this information.